Hello, and thank you for joining me on my presentation on integrated datasets within integrated product support. My name is Bruno, and I'm the Business Development Manager for Pennant in the Asia Pacific region. And today I'm going to cover off on some of the benefits to integrated toolsets within IPS. Before we get started, I would just like to cover off on some of the basic terms within IPS to get everybody on the same page. Of course, a product always starts with a concept, and this could be a requirements definition from the end customer, let's say the Ministry of Defence or Department of Defence, or this could be a solution originally developed by an original equipment manufacturer and then sold on to that end customer. Once the requirements definition and concept is all agreed upon, the design of the solution begins. Engineering design is the process of creating this solution to meet these conceptual requirements. In step with the engineering design is the support design, or the design of the support system. This is establishing some of the support system elements such as the levels of repair, preventive maintenance schedules, building your supply chain pipeline, trying to get an idea of labour requirements, training requirements, etc., as we will go through. IPS does call upon a number of tools within the system, one of these being the product lifecycle management tool. An example of a PLM tool would be Siemens Teamcenter. The purpose of PLM tools is to manage the engineering baseline of the product throughout its acquisition, sustainment and disposal phases, and acts as the source of truth for approved data. Getting into the nitty-gritty of IPS now, we start to look at logistics support analysis records, or LSARs. The purpose of LSARs is to capture, organise and manage all of the logistics related data for a system throughout its life cycle. LSAR data is also the backbone for some of the tasks that come downstream, such as support modelling and technical publications development. We talk about support modelling, and this is a way of using that LSAR data to help drive some decisions regarding level of repair, regarding sparing and lifecycle costing. It can also provide some operational insights if that concept has been determined yet through simulations of the support system against certain scenarios. We also need to start building our supply support solution. We are talking about warehouse locations, provisioning and procurement, inventory control, etc. For IPS itself, we're probably more interested in the warehouse locations, resupply networks, and those turnaround times for repairs, potentially item min-max limits on shelves, those kinds of things. Of course, we need to develop some technical publications, and these are the structured, standardised operation and maintenance manuals that are used to support the system once it's in service. These technical publications and the data that they use are also used to create training solutions. End users obviously need to be trained on how to operate and maintain the system. So a training needs analysis happens using that data, and then the appropriate courseware is developed. Once all of this is done, we have a final product, and that product is not only the system itself, but also the support system that will keep it operational during its life cycle. So I just want to go through some of those terms in a bit of a linear or timeline view to have a look at how this all gets pieced together. Some projects may slightly differ from what I'm about to present, but I think generally this is going to be quite common for everyone watching. So we start with our concept. Once agreed, we begin the design phase. That is engineering and support design working side by side. The design baselines are then loaded into the PLM tool, and that manages what is approved, what is not approved, what is in work, etc. Once the appropriate data has been populated, that will then begin to feed into an LSAR tool. That LSAR tool will help to determine some of the material management and supply support processes, as well as feed into a supportability model, which will help to determine sparing requirements, shine some light on lifecycle costing, those sorts of things. Depending on the output of this, the model may influence some of the design factors as well to make that more efficient. This same data from the LSAR is used to populate some technical publications, which will develop operational and maintenance manuals, which will be delivered with the project. That data is also used to build a training solution, and then we roll into the final product itself, as well as all the supporting documents and processes. So now we've covered off on that, we can see that there's quite a lot of steps involved in conducting integrated product support. And each of these steps needs particular software to help that happen. And often this is all separate software tools. So we look at some of the typical silos within IPS toolsets. We have engineering design tools, and that's a bit of a cover-all for probably a number of tools that engineers use to design systems. We have PLM tools, I mentioned an example earlier. LSAR tools to build that logistics support analysis record. Modeling tools, which may be one or multiple, which cover off on multiple facets of modeling. Material management or inventory management tools. The technical publication software, which could be the development, the publishing or the viewing of some of those tech pubs. And training management systems, learning management systems as well, to cover off on some of the training development. So with that in mind, I would like to run through an example of a common and simple update to the engineering baseline, such as a part number change, and how that may affect all of these different tools within the IPS process. So let's say that engineers have gone through an engineering analysis and identified a new part number that they would like added to the baseline. That new part number, once approved, needs to be reflected within the PLM tool. Remember, this is covering off on the approved baseline for the system. Because this is a new part and it does affect IPS artifacts, that needs to also be reflected in the LSAR. Once the LSAR has been updated, supportability models also need to be updated. This new part may have different characteristics which affect some of those model outputs. Inventory management systems need to be updated. Of course, when you are procuring parts, you want to procure the parts that are approved to go onto this system. We don't want to be approving old parts which are not approved. The technical publications also need to be updated to reflect this. This new part may have a different look, feel, different procedures for testing, installation, etc. So the technical publications, it's critical for those to be updated as well. And of course, the training systems also need to be updated, so the training packages reflect the latest baseline of the system. So we can see here that there are probably 6 different updates that need to happen for a common and simple update such as a new part number being added to the build. Now, IPS is only one part of a project, and we've already noticed that there are 6 changes that need to happen based on one simple engineering change. You can probably imagine a lot of the other changes and management of tools and updates that happen within a project. I'm thinking accounting software, project management software, etc. So when we're conducting changes on such a large number of tools, this can introduce some errors. There can be integration issues between all of these 6 tools that we've just discovered. File formats, the output of one tool and the input of one tool may not be exactly the same, so some manual changing needs to happen to have these tools talk to each other. Of course, these manual changes usually done by people and can introduce errors potentially, and those errors can flow through the system if they're not picked up. IPS practitioners need to learn multiple different systems with different interfaces. Words may mean different things depending on what the vendor's interpretation is. So this can get quite complex and confusing. When you're switching context between these programs, this can slow down productivity. And of course, version mismatches between tools can cause unexpected behavior. Maybe one day things are working as they should, one program becomes updated, and then all of a sudden things are not as they were the day before, and there's some learning that needs to happen to make these things talk to each other again. All of this takes more time than it probably should and is less efficient than I think everyone would like it to be. Of course, depending on the system, security classifications, all of the compliance requirements, this could potentially cause some issues there. You have data going in and out of systems. Where does that data go when it's exported from one system, held somewhere before loaded onto the next system? That can get a little bit murky. And of course, audit trails may be fragmented or incomplete, trying to track back where data has gone and how it was managed throughout that process. If there are issues, troubleshooting becomes more complex. We have multiple tools which may do slightly different things, and we need to try and backtrack when there is an issue to pinpoint where the issue or the root cause of the issue actually was. That gets quite complicated across multiple tools. And of course, if you have updates in one tool or something not working in one tool and other tools that you're also managing, the vendor support may not be able to help fix any problems that you have if they're from a tool from another vendor. That can get quite complicated as well. All in all, this is probably slower and less efficient than we would like. Maybe not insurmountable, however, we are introducing quite a lot of manual touch points which introduce more points of failure in the workflow. One small issue can span across these tools potentially and make it quite difficult to actually pinpoint anywhere that point of failure might be. So let's think about what a perfect solution might be and how we can overcome all of these issues. Now, ideally, all of these tools use very similar data, and there are IPS standards out there which are designed to make data transfer smoother and easier. However, let's imagine for a minute that we have a database which is centralized and holds all of this common information to feed all of these tools within the IPS project, from engineering right through to training. So we think about that same example where a part number has been changed. Engineers have identified the new part number that's been approved and loaded into the PLM tool. And that part number is then updated in a central database. All these other IPS artifacts and tools, LSAR, support models, technical publications, talk to the same database, so that part number is automatically reflected in all of your IPS artifacts. There is no manual work needed to make these tools talk to each other. There is no repetitive data entry needed to get everything in step and in line. Now, this may be the inverse of what I've just spoken about when we talk about problems of segmented toolsets within IPS. However, let's go through it. If that ideal solution did exist, that would create a number of benefits and efficiencies within the IPS project. We don't have to worry about file formats or data structures being different or not talking to each other, because they would be designed to work together. In fact, there ideally would be no manual data transfer between these tools, and the updates would automatically flow and cascade through the system. The workflow becomes a lot simpler. We don't need to worry about updating this tool, and then talking to someone else to update the next tool. Again, once that approved change has happened, that is automatically updated in all your artifacts. If all of these tools came from the same vendor, or at least vendors that communicated with each other, you wouldn't have to worry about software version mismatches or updates throwing things out of whack, because it would all be designed to work together, and updates should consider what the other tools are doing. Obviously, we spoke about 6 tools being updated previously. If this ideal solution did exist, there would simply be one change needed and everything up to date. This would reduce the amount of manual touch points within the process and maximize automation to a level that could potentially be 100%. There would be no need for storing data outside of these systems to then tinker with it and have it integrate with other systems. If we're all drawing off the same database, that database is in a secure environment and a compliant environment, then those changes would flow through without having to leave the system. Troubleshooting becomes a lot simpler because you're dealing with one point of contact, and updates reflected across all of the tools should be quite easy to follow back, because if these tools are talking to each other, you should be able to trace back the steps taken to make certain changes. And as I spoke about with updates from vendors, or if it is just one vendor, those updates having the other tools in mind, software updates shouldn't be throwing out compatibility between these tools. Of course, this all ends up in a faster, more efficient, more stable workflow within the IPS process of reflecting engineering changes all the way through to technical publications and training solutions, updating support models. That all becomes quite a lot simpler and changes safer. Now, I don't believe any tool or vendor out there actually does this in terms of developing every single tool or one tool that does all of these things. However, here at Pennant, we have done the next best thing, which is develop a suite of tools that do talk to each other and do integrate through a central database, and partner with other organizations to fill those gaps that Pennant doesn't provide. This is called Auxilium. Auxilium is a suite of tools that cover your LSAR requirements, supportability modeling requirements, and technical publications development and publication. These do work off a central database, and we have APIs into partnering organisations which cover off on the inventory management systems, the PLM systems, and the training management systems as well. These LSARs are standard compliant, so deliverables out of the LSAR can be sent directly to some of these other systems like the S2000M or inventory management system or training management system directly from the Auxilium database. These updates to LSARs, so let's think part number change, are automatically flowed through to technical publications without lengthy and cumbersome data update processes. And of course, partnership and integration with these complementary tools mean that the customer gets a comprehensive and seamless solution from minimal vendors to cover off on that entire IPS process. So let's dig into Auxilium a little bit more. Auxilium is the systems support software suite. We're talking about GenS, which is an LSAR tool, Analyzer, which is a support modelling tool, and R4I being the S1000D technical publications development software suite. This is designed to ensure systems are where they're needed, when they're needed, and that they work. We spoke about the benefits of using a common database. Well, this is what Auxilium does. We are aligned to all of the global standards and specifications, or at least the major ones, and doing this ensures traceability and integrity of data, as well as all of those other solutions that we just covered off on. Breaking down Auxilium a little bit more, of course we have our integrated database, the common data repository and single source of truth that ensures traceability and integrity and supports a wide range of global standards and specifications. GenS, our LSA or configuration management tool, improves the availability and reliability of systems by ensuring that maintenance and support is well planned and cost is optimised. Our Analyzer model-based supportability and analysis tool makes informed decisions for an asset's lifecycle support solution. And R4I creates S1000D and ATA standard technical manuals, which can be published in PDF or IETP format. As I mentioned, no one vendor covers off on all of the things that we spoke about earlier. However, Pennant has done the next best thing by covering off on 3, which do work off an integrated database. So with all of that in mind, let's run through the part number change example if an organisation was using the Auxilium tool suite and its complementary partners. Engineering identifies a new part number, and that is then fed to the PLM tool where it gets approved. That updated part number would be fed into the central database and updated in GenS, in Analyzer, and in R4I, all automatically once that change is done once. Through APIs to partner software solutions, the material management and training systems would also be updated to reflect that change. So you can see how with the Auxilium and partnering solutions, it goes from 6 manual updates to potentially 1 single update, which updates all tools within the IPS processes. So why would you use Auxilium? It is a single integrated tool suite, meaning a single tool vendor, and thus significantly reducing vendor management and commercial overhead to save time. There's equivalent single products in the market. However, it is rare for them to be combined into a single package, as well as the complementary partners into a single source of truth database, ensuring that traceability and data integrity. The ability to exploit this data and derive detailed business insights enables organisations to make data-driven decisions, which can save significant cost. Thank you very much for listening. Please reach out to me if you would like to speak further or have any questions. Have a good day.